What is blood doping?
Okay, blood doping is, all right, like the scenario that I just gave you.
Isn't that what Lance Armstrong got in trouble for?
Now, in that case, okay, well, I can't say because I don't know for sure. So I will just say in the case of blood doping, the goal is to increase the production of the red blood cells. Now, this can be done medically, okay? Or it can be done for athletes who want to not have a drug in their system, okay? They can go to higher altitudes, train in these higher altitudes, come back to their events that will be at a lower altitude and have the advantage.
And that's bad? Or is it?
It's called blood doping?
It's called blood doping.
That doesn't
feel like
seem
it's
like that
like
would be wrong.
utilizing
though,
your
if you went and
environment.
trained in a higher altitude.
Not if you're going to go do it that way, but the ones who want to do it the quick way.
Can't you eat stuff to increase blood cell production?
I have to look that up.
How's it done medically?
Because
I'm sorry, I'm so sorry.
Erythropoietin is a hormone.
Huh?
Erythropoietin is a hormone.
But I mean, like, do they,
You can take injections.
okay, I didn't know too, I thought, wasn't there like some blood changing going on? Like, inputting of blood with?
Yeah, that can be done
Answer.
also. Yeah,
It was, yeah, he was getting blood put in his body.
yeah. And you're increasing the red blood cell count because you're not losing
I
it.
gotta go watch that documentaries on HBO.
Yeah, you're not losing the blood and you're still adding to it.
I don't know if this is like a bunch of hippie mess, but when I was hiking up in it was like southern Colorado and northern New Mexico,
Okay.
and the mountain ranges I was in, it was like 10,000 to 12,000 feet.
Okay.
And I got really, really sick when I was up there, and I passed out because I like leaned over and I fell face first. But the guy I was with, he made me eat a lot of kimchi because he said it increases red blood cell production, and it was like beet kimchi, and he made me eat like red stuff.
Because people associate the eating of beets with the effect of the heart. Now, whether that's true or not, I don't know.
Okay.
But I just know that some people believe that, like Megan's picture that she posted, I loved it because people really do believe that if they eat for that particular part that's giving them an issue, they eat that particular food, that it's going to make them better. I don't know if that's true or not.
Yeah, he would just make us eat a lot of kimchi before we went hiking that high, so we wouldn't get sick again.
But it was
It
beets,
seemed to
not cabbage.
It was not. It was cabbage and beet kimchi that we had
Oh,
made.
both together?
Yeah, it was just like a weird mix of
Can't handle
fermented.
Fermented.
Yeah. Yeah.
I don't know. I always just felt that was weird. I guess this is healthy.
You have stumped me on that one, so I will have to think about it.
They sell like compressed oxygen little. I lived in Breckenridge before I came back for school, and we worked at like 11,000 feet, and we sold like little compressed containers of oxygen that people from out of town could take to help them with their.
The reason for you've heard of a oxygen bar,
Yeah.
right?
Yeah.
Have you ever been to one? It is fun, you know, because you don't really realize how much you're not breathing correctly. And so, you know me, I saw the oxygen bar and I was just like, oh yeah, man, I gotta try that out. Okay, so, you know, and it's, you know, you go in there and you're breathing that oxygen, but see, it's temporary. So they would probably have to come back and get more.
Wouldn't that be
for
highly
it.
flammable?
Sure. You don't want to smoke around it. Yeah.
Yeah.
But it does make you feel better. I mean, it like, you know, breathing in
I
that
met
pure
a dude who
oxygen.
said he would go to the oxygen bar after like really intense workouts. He said
Yeah.
that it just got rid of all the soreness.
Mhm.
Oh,
And that's why he did it.
Yeah. because it helps to get, you know, as long as they were drinking the fluids, okay, getting that lactic acid out. When we begin to increase our exercise, like if we start an exercise regimen, okay, and we continue that regimen, you will see an increase in your red blood cell count. Now, it's not anything that happens rapidly, okay? Your body will adjust to it as you increase the exercise. Now, lung tissue that gets lost in breathing disorders, okay? Even though, for example, emphysema, the person can, you know, they're breathing in, okay, but their actual distribution of the oxygen into the bloodstream is what's wrong. So it makes them feel as if they're not getting enough oxygen, when in reality they're getting it in there, but the surface area for the diffusion of oxygen has changed, okay? So it's not utilized. So you would have all of this stuff, so at the tissue level, when the kidneys detect not enough oxygen, they want to make that erythropoietin so they can get it to the kidneys to stimulate the production of the red blood cells. When the red blood cells are done, okay, they've had their 120 days of fun, they're going to begin, as they move through the spleen and the liver, they're going to be broken down. They're going to begin to rupture. Because at this point, that red blood cell, as it has had to squeeze and squeeze through so many capillaries, it is like, you know, the plasma membrane of it's worn down. Because remember, it doesn't have organelles to reform a lot of stuff, okay? So it just gets beat up and beat up and beat up as it's going through those capillaries. So as it begins to make its way through the spleen and the liver. For example, do you guys remember reticular tissue? The fibers that were reticular, we've got the collagen, we've got the elastic, and we've got the reticular. And reticular made these little spiky webs, okay? So as that red blood cell comes flowing through these organs that have that structure, they get caught on the little spiky reticular fibers, and then they just begin to break apart. Now, that means that as they break apart, we're going to have to make sure that we can either reduce, reuse, or recycle, or get rid of the components of that red blood cell.
Is this where granulations come from?
The what, huh?
Granulations? Like in brain disorders or whatever, when the macrophages are coming to get the...
No, usually
damage.
what happens with that, if I'm following correctly, there's been damage to the brain tissue itself, and the brain tissue is dead. And so the cells that are functioning as macrophages in the brain come to eat up the dead cell parts,
Okay.
if I'm following
I
correctly.
thought these would be granulations because they're broken up too, right? If they're bits. Yeah.
I've never heard of the little pieces of a red blood cell being referred to as a granulation. I'm not saying that's not the case. I've just never heard of that.
Okay.
For a red blood cell that's destroyed. I've just never heard of that, okay? So as we begin to look at that red blood cell, remember, the red blood cell has its plasma membrane and it's got its hemoglobin. The hemoglobin is that quaternary structure, and it has on it the heme group. So we need to make sure we destroy the little membrane pieces. We need to separate that heme group from those globin molecules, making up the hemoglobin. So when we get to the spleen, because that's the biggest organ, okay, that's going to take care of it. But the liver can do this also, just really would rather be doing other stuff, okay, but it can. So, what are we going to need to do? We need to take that globin molecule, which is a protein. Proteins are made up of amino acids. So we need to take that and break down those amino acids. So if we can hydrolyze, meaning we break down those amino acids, we can return them to the bloodstream to be used for making more proteins. Does that make sense? The heme portion, okay? For the heme portion, heme has the iron. So we've got to make sure that we remove the iron from that heme group that was in the middle of that globe making up the hemoglobin. Does that make sense? Now, iron, okay, we're going to remove the heme, okay, that portion on the hemoglobin. The pigment is going to become what's termed biliverdin, and it has a green tint to it. We're going to have to take that and convert it to bilirubin. Does that sound familiar? Now, how do we think of, or have we heard of bilirubin? Jaundice, which is something from the liver, okay? Now, our iron, in the meantime, that has been sent back to the bone marrow so that it can be incorporated into the hemoglobin molecules of new red blood cells. So the heme, some of it gets turned into biliverdin, which will have a green color. That gets converted to bilirubin, which is yellow. That will now be released into the blood plasma, and it's going to be making its way to the kidneys so that it can be gotten rid of. All right? And it's one of the things that can add the yellow tint to our urine. So once we make it to the liver will take that bilirubin and secrete it into bile. What becomes bile, okay, we'll see in the gallbladder, which will go to the small intestines. Bacteria take this bilirubin, we can have it turned into urobilinogen. The only thing that we can create from that point is feces, and it helps to give feces the color that it has. So when a red blood cell breaks down, or when a red blood cell dies, we've got to get those little pieces of the membrane eaten up. Then we've got to recycle the iron. We really need to do that. Okay, the body really needs to function really well. Recycle that iron back to the bone marrow for the hemoglobin molecules, okay? And then for the heme, break that down and get rid of it. So the body, for the most part, is going to get rid of it through our urine and our feces.
Now, does that process take days or seconds, minutes? I mean, because that's a lot of steps, so. I mean, obviously, lots of
I don't think it takes days. I think it's a continual process, so probably more than seconds. I would think maybe minutes to hours. I've never seen any information on that.